last e-learning package what we have, or lesson what we have been produced in the ROADEX network, and it's called Gravel and Forest Roads, and it's published 3 weeks ago, so we can see that it's a brand new uh, material what you will see now. So ROADEX e-learning, a little bit about history of ROADEX e-learning. So I guess every one of you are and know about ROADEX project. It started 25 years ago, 1998, and it's composed first 4 ROADEX projects, 1, 2, 3, and 4. And after that, it's been continuing as a ROADEX network. This first project were partly funded also by EU, but now it's partners are funding. And and one of the big ideas is the rural node, and ROADEX is focusing very much on rural roads. And one big idea is the share the knowledge and best practices of rural roads in Northern Europe, including also like forest roads, not only public rural road, but forest roads. And in 2008 we started to build first e-learning package. So it is already 15 years ago, and at that time e-learning was not so common as it is now, but in that way we were one of the pioneers in these areas, and we've been producing these reports, and within this 15 years we are proud to tell that as far as I know is this ROADEX e-learning is the absolutely the most popular open e-learning package related to the road engineering in the world. And when we made this system, these packages and started to, so the main idea is that we will share this only on ROADEX partner areas, which is Nordic countries plus Scotland plus Ireland plus Greenland in the that were the partners. But here in this map you can see locations. So we have at the moment 10,000 monthly users, and they are not bots. So we are filtering bots out. They are the users that are really going and spending their time. And at the moment it is interesting that like number 1 is China, but then it comes Philippines, India. For instance, earlier Indonesia was very popular, and first ROADEX country, or actually it's UK, but partly like Scotland is 7th, and Finland is 9th, and then Sweden is 13th, and Norway is 14th. But this has become very popular among users. And when we've been analyzing also and analyzing demographics so about our users, so it's very popular in young among young people and students, and in many universities or universities applied sciences, and so it is also on the teachers are telling to go there. But still, even like a 45 to 65 among in between these years, so almost 20% of the users are. So us like my age veterans are also like using that quite much. Very interesting also over the years it has been to find the gender, that when we started 15 years ago, it was this area was very much male dominant, but at the moment females who are checking our website are more than 50%. So 53.5% are already female. So female users. So in that way, civil engineering and road engineering is getting more and more popular, becoming more and more popular among females. So then about e-learning lessons, if you haven't been visiting yet, so we produced earlier 4 lessons. So we started permanent deformations, which were mainly, I think, we started 2008. I think it was 2009 ready, and then after that we were made roads on peat. Very interesting and important issue because there were not so much public data and school books available on that. Then very common and an important issue was drainage on low volume roads and environmental, later on environmental considerations. And now we have this lesson 5, gravel and forest roads. Earlier, when ROADEX had more money, we have been translating these reports and packages from English also to all the languages in ROADEX partner countries. But now, due to the limited resources, so the upgrades, all the upgrades are in English. So if you go and look e-learning in your own language, other than English, so you will see something, but it's not the latest version. All the latest versions of these packages are English. Later on, if and when ROADEX continues, we will discuss if this will be translated to these languages again. So gravel and forest road e-learning has been there for 3 weeks, and already we have had about it was 2 days ago, we have about 8,300 users, so it's pretty good. Already almost 3,000 users per week, and it shows again that it has been quite much interested. The average time has been 3 minutes, so it's not just go and visit. And so far the most important or the most popular lessons have been the number 2, road components, then renovation design and renovation design and renovation techniques, and then bearing capacity. But almost all of them have been visited quite good time. Then going to starting to focus on this package itself. So this production team was 3 men. In addition to me, that was the main author. Ron Monroe was my right hand and was helping a lot and have been writing also part of that and checking everything. And then on technical and artistic design has been Mika Pyhähuhta, and his company has been responsible on that and Mika is from Laboratorio Uleabori from Oulu, Finland, and Ron is from Scotland. And special thanks is Hafdis Eglo Junsdottir, who has been providing a lot of valuable material and help. And if you have already visited this e-learning, you will see a lot of beautiful photos and very informative photos and videos that Hafdis has kindly given us to be used in this package. Gravel and forest road e-learning contents. We have 11 lessons. Then the traditional lesson test that checks that if you have understood correctly what's there and remember everything else. If after each lessons on over there, it's a 1. And then Also, one thing what hasn't been there before is video links. So in YouTube, especially YouTube is providing currently a lot of very nice videos about gravel and or about road maintenance in general. But what I did was that viewed dozens and dozens of videos from all countries and picked ones that I thought they will be quite interesting for you also to see. Some of them are pretty funny also. Then it's a quite comprehensive literature rich and references and guidelines list. We've been trying to get the most latest guidelines for gravel and forest road from each countries over there. And finally there's acknowledgements. Then started to go quickly through the chapters. So first chapter is general, where we are telling in general what is gravel road and what is forest road and how important they are, and also telling about in ROADEX areas, like for instance Ireland and Scotland, there are no gravel roads at all, but then on the other hand forest road, the amount of forest road is quite substantial. On the other hand, Iceland has huge amount of gravel roads, almost as much as in Norway, or at least half of them, but then there is no forest roads. Even though I've been driving in eastern Iceland in some gravel roads in the middle of forest, but they were public roads. And then in Finland and Norway and Sweden, you can see the number, and especially the number of forest road in Sweden is very impressive. 2,080,000 kilometers of forest road. Tells about also important about forest industry, especially in Sweden and Finland. And one interesting feature in this one chapter, that even though you are not so much interested on gravel roads, but there's an interactive system of photos of different type of gravel roads in Iceland. And you will see a map, and if you click these maps, so always like in this case, you click on this F26 and see the primary, so you will see a photo. And it's at least on my opinion, it's amazing. You can make an amazing tour all around Iceland and see also gravel roads over there. It's fantastic. Thanks to Hafdis, she did a great work to collect this. Chapter 2 tells about gravel and forest road components in general, about typical cross sections. There were some variations on different countries, so this is my understanding about an average cross section between each countries. So it's not like a one individual type, but I tried to make a very typical compromise of different type of systems. So for instance, gravel roads in general is 5.75 to 6.22 to 5 meters. I know right now in Finland we are very much working on 6.5, and the latest goal is that we will widen gravel roads up to 7 meters. But anyway, there are some changes. Then talking about cross falls, inside slope, outside slope, dips, depths, etc. And so this is, then we are talking about road structures, drainage components, and bridges and some other assets also. One interesting on issue on forest road was also the new idea, and this is, I would say that this could be started to be used also in other countries, that this idea of running with and top structure with, and running with means that it's the area where you have the wearing course. But the new idea is that this top structure width should be about 50 centimeter. And now, especially with the new and heavier trucks, so the idea is that from the outer wheel you have at least 1 meter supporting road shoulder is very good, and I think it's an excellent idea that this has been started, and this idea came from Scotland, and I think it's very warmly recommended to be used in other countries. Also, another idea that I haven't seen too much in other every areas is the design of forest road, because forest roads are very much like roads that have an end somewhere, dead end somewhere. So you are collecting timber and then driving back. So the vertical geometry can be different. So so when you are that direction where you are hauling timber on the loaded, so the vertical geometry is 10%, and then unloaded 12%. I think it's quite nice idea also about very much saving money in especially in hill country areas. Then the other example, there is a lot of other issues also, but I took just on this presentation another example of about bridges. And one idea that it's not in every countries, but those who have been using it's been very like useful, especially on gravel roads, that if you have bridges, so you are putting a pavement both sides of the bridges, and there are two issues on that. One or two reasons for that. One is that if you have this paved road section, so you are avoiding potholes, because bridge joints and this unevenness is causing very much potholes. But the other reason is that once you are using dust binders, chlorides, and these dust binders are going also with the sand to the bridges, and especially concrete bridges. So you might cause some extra corrosion on the bridge decks. So that is it is protecting that also. So it is, I would say, could be considered as one of the best practice issues on the bridges. A lot of text is about wearing course. That's part of my favorite issue, because I've been doing research on gravel road wearing course already since 1981. So very almost 50. Actually, it's 40 years ago, more than 40 years ago, and about the wearing course, and one issue what we are explaining here is it's a very nice history about how wearing course grading came. And I don't know, I've been hearing that from old engineer when I started my road career, and I don't know if it's urban story. I haven't seen any report, but it was thought to be true that the history comes from Sweden, and in 20s and 30s in Sweden, there was a research on gravel road wearing course material, and first of all they were checking the material on the roads where they had dusting problem and they didn't have a dusting problem, and and in this case, this green area was where red arrow showed where they didn't have dusting problems, and then they were studying also wearing courses where they didn't have a deformation or wetting problems, plastic deformation problem, and that was the blue. And then the area between these gradings were selected to be the optimum grain size distribution of the wearing course. And at least I don't absolutely know if it's the true story, but it's a nice story and easy to believe that it happened. Another issue on which is new one, and this is only about, I would say that maybe 20 to 30 years ago, on the gravel road wearing course. In that before that we were talking about very much about cohesion on that, why what is needed in that it's a binding. But in USA in 80s it started to spread this thermodynamic theory and especially suction theory. And suction is a thermodynamic force that that keeps the particles together. And suction theory explains why we have to have fines in the material, or why we need to, if we don't have enough fines, we need to put chlorides. So because suction is composed of two issues. It's a matrix suction, that is, the higher matrix suction is, the more you have fines content. And matrix suction, as in this graph, sees that the drier the material is, it is like clay. Dry clay is very stiff and hard, but once it starts to get wet, it becomes plastic. So as I said, here is fines content is very much related, and stiffness. The other issue, on the other hand, is osmotic suction. Osmotic forces and osmotic suction is not dependent on, it's not independent on water content. But if you don't have enough forces to keep the binders together, what you can see then, like in the left photos, that all the big pebbles are thrown to the outer curves, or you have a major dusting problems. On the other hand, if you have too much suction, if you have too much fines, or if you have been using too much chloride, then your problem is what you can see on the right hand photo, that you have permanent deformation, or plastic, even in the worst case, plastic deformation on the material. So this is explained on these graphs. Also some ideas about aggregate quality, some comparisons of Icelandic works. Iceland did a comparison of aggregate quality and how it should be studied on material wearing course aggregate. And it's quite big changes, but very interesting comparisons also on that. Then other issue that we have found, or what we have found already more than 20 years ago in road scanners in late 90s, when road scanners started, we did research on gravel roads. And one first thing what we found already is that if you assume that the wearing course thickness is even, or like in asphalt roads, so you are totally wrong on this. So it is changing, the thickness is changing a lot in both in transverse direction and also in longitudinal direction, because of grading and everything else. On the top over there, you can see a gravel road cross section from Siekasjärvi, Sweden, northern Sweden, where you can see that on the wheel path, you have about 60 centimeter of wearing course. Once then in between the field bed, you have hardly anything. And this means that when you have a mode 2 rutting and grading graders are making that even, so you are just increasing. And here the other example is from GPR data, ground penetrating radar data, where we've been doing research. And over there, what we found also very interesting finding is that on the top of the hill, because graders or trucks with the underblades, they have tires. So underblades, if you don't adjust underblade cutting depth, so it's cutting always, and then it is moving the material to the bottom of these valleys, and that means that in the top hills very often you don't have wearing course at all, but in the bottom, like in this case, there is about 30 centimeter. And once we know that if you're wearing course with high fines, like 12% of fines content, if your wearing course thickness is more than 10 centimeter, you will have a very high risk for spring thaw weakening, especially surface thaw weakening. And we will tell it is showing, like in this case, that on the bottom of these areas you are seeing already starting surface thaw weakening, plastic deformation here again. And that is one reason why we should measure, let's say, at least once per 10 year, the wearing courses, and then if they are too thick, it's a one way of avoiding plastic deformation, that then cutting too big wearing course thicknesses away from these sections. Also, wearing course maintenance techniques, quite much on over there. Don't have time to, but there's a lot of text what should be done on the spring, summer, fall, and winter maintenance. And one special issue over there is what we are addressing is the importance of compaction. Also, what we tell that especially if you don't have a proper compaction system, like in these photos in Iceland, you should use salt, because salt is salt is helps with the compaction, and we are talking about theory. I don't have time to tell why this is, but if you are using salt on when you are in the especially spring maintenance, then it forgives a little bit more if you are not using proper compaction. The other issue, or especially special issue on winter maintenance, you have seen on the top right photos, is the removal of snow walls. This photo is from North America, but again, showing that before spring comes, you should remove almost all the snow away from the road, because this melting snow is water from the melting snow is due to the cruise action is going under the pavement road structures, and then you have a spring thaw weakening. And this snow removal is also changing the microclimate. So basically the evaporation, because if you have high snow walls, sun is shining, there's like a cold spot in over there. But if there is as there are no snow walls, the evaporation is much higher, and the pavement surface or road surface is drying much faster. Chapter 4, bearing capacity. There is just comparison of gravel road design principles. In this case is comparison of Swedish and Finnish design principles, slightly different. in Sweden, all the gravel roads have a same basic, and the only changes is climate zones. So depending if you are on the southern Sweden, where you have a climate zone 1, or in the northern Sweden, where you have a climate zone 4 or 5, the thicknesses are slightly bigger, thicker, and then it depends also the thickness if you have a non-frost susceptible sand or gravel, or if you are on the silty subgrade. In Finland, on the other hand, we don't have this variation on the geographic area. We are here is just like the type of gravel road. It's a public gravel road with a lot of traffic, important role in the road network. It's a 80 megapascal road, and then a slightly not so important road, so 70 megapascals, and then gravel road and private roads. It's they are called 60 megapascal roads, and as they have slightly thinner structures. But in Finland, this is a standard system. As a comparison, we put also like in US, where there are about 1 million kilometer of gravel roads, public gravel roads. So there is a design principle in USA and different. Also, it is pretty much same as Swedish, but then they have a traffic level also. If it's a high traffic or medium or low traffic, so it's in that way a little bit. It's a little bit combination, but if you are comparing the total thicknesses of each geographic area in USA and Nordic countries, we are getting up pretty much on the same level. Forest road comparison is from Finland and Scotland. What we published, we went through all the others also, but I think they were interesting in that way that in Scotland we are. It's and the like a defining factor is CBR, that you can measure CBR on the laboratory or with the DCB in the field, and with that, and of course you can define the subgrade soil, and then that defines then on the what is the structural thickness. One special thing, what I already said, that this width of the surface is that formation width is that if you are on the rock or sandy gravel, and the top width of the structure is 5.4, but once you go to silty clay or peat, it has to be 7 meters, which is very nice way of thinking, because in that way you are fighting against mode 2 rutting on these roads. Finally, we are also like showing, of course, because this is a ROADEX recommendation, when we did a lot of research on forest roads and their performance. This is our recommendation about target bearing capacity and classifications. So basically, if you are on 85 to 110 megapascals surface bearing capacity, for instance, falling weight measured, it's acceptable. You can have minor problems probably during very bad spring thaw weakening, but nothing else. And if you are higher than 110, then it's acceptable. And in Finland, on the right hand side, it is the Finland, and over there it's a similar classification as with the public road, but it's 80, 60. It's a meganewtons, but the lowest forest road is as low as 50 meganewtons or megapascals. Chapter 5 is roads on weak subgrade, which is very much the same information what is roads on peat, but a little bit more information, new information. Also telling about consolidation or settlement when you are building a forest road or gravel road, how it takes place. And for instance, a very good idea that if you want to see, like if you are building a gravel road or forest road, that 1 week your after primary consolidation, you are halfway with the total settlements. So that's a very nice rule of thumb, that once you measure and you see where the bottom of the structure is, then within the next 30 years, because secondary consolidation is so low that it takes next 30 years to get the other 50%. Then we are explaining quite much also about what is pumping and why we have a failures, especially on the peat, on the at the end of peat box. And that is, the reason is that especially on the big trucks, that when you are saying that with the big timber trucks that road is recovering and behind the tires, but especially with the heat, this doesn't. It's not true at all. And an example of this kind of timber trucks on the last triple bogie axle is always the highest one. And that, if this is the case, so it means that the road structure starts, when the truck is moving, road structure starts to push water in front of them. And when it comes to the end of the peat box, or there are some obstacle around, it pushes up, and then you are getting this pumping effect. Roads on weak subgrade, also falling weight, some rule of thumb of falling weight. How do you know it is if there is peat under the road? There's a very nice rule, this 1200 millimeter geophone. If its deflection is 200 micrometer, you are, I would say, 90% sure that your road is resting on peat. Also, if you have 200 micron on that and maximum deflection is more than 2500, you can have a problem. But if the maximum deflection is more than 3500, you can be sure that you have issues with the heavy trucks. Also, some example about how to handle. Very nice example, especially on forest roads, is that if you have a peat, so you are building immediately slightly overload embankment. So you are taking that, and on these areas where you start to get settlements, so you are using with the grader and make it even. The other issue in Nordic countries, good part with this is that once you have your grade line is slightly higher than anywhere, so it is snow accumulation is lower because wind takes care of the snow. And the other, what we have been doing in ROADEX research and some other projects and very good experience, is using the steel grid structures. In the beginning, where you enter to the peat area, and on the other side of that. This is excellent tool to prevent these pumping problems. Drainage is we have a different drainage e-learning, where there is quite much also on the gravel road, but again, repeating drainage, that we have just showing what type of drainage problems we have, what are the drainage components, and how do you should do drainage maintenance. But one issue what we have been finding out, especially in Finland over the last years, is, for instance, if you have a potholes, you are most likely, I would say 80% of the cases, you have a problems with the drainage. At least on the spring, even though in the summer you don't see too much water, but if you come to these pothole areas in the spring, they very often look like that. And then you have a pothole problems over the summer. The other is erosion, especially on the hilly areas or mountainous areas. If you have verges on the roads and water doesn't flow and under the heavy road, you might have a big problem. Third one is clogged ditches, which is especially affecting the shoulder deformation. Your ditches definitely need to work well, otherwise you will see problems like this. And then in especially on here in the north is differential frost heave. For instance, in this case is a nice case. You see a small boulder here. This boulder or big boulder, a little bit bigger than football size boulder, is on the bottom of the ditch, and it start to block the water flow. And in next winter, you had a huge frost bump on this section. So even in one individual boulder can cause a frost bump on the roads. Drainage also about technologies on drainage, widening of the roads. This is, sorry about this is the ditch bottom. So showing how you can measure with the laser scanner the cross section of the road, and also where from the GPI you see the bottom of the pavement structure or road structure, and then you see the ditches, red and blue one, and once red means left ditch, which is here, and ditches should be always deeper than bottom of the road structure. And once they are here very high up, you start to see immediately some deformation problems. And also when with the GPI, you measuring dielectric value, which tells you about moisture content in the wearing, because you are measuring very high values. So this is a risk, definitely a risk area for surface toe weakening. The other issue on the drainage, which is now, for instance, in Finland, we are starting to pay more focus on that, is the fact that if you have drainage problems and the pavement structure is wet, what is happening is, first of all, your cross section road is starting to be flattened because of mode 2 rutting. It's pushing material aside. So what you can see is widening of the road based on the laser scanner data, and flattening. And flattening means that, okay, especially on the road center goes down and the road gets wider. And these two parameters are, like in this case, the design width of this road is about 5.5 meter. And in this, for instance, in this section, we are around almost 7 meter wide road where you see the spring toe weakening problem. So very nice indication of this is that when the road gets wider and flatter, you are having also most likely also a drainage issue. Chapter 7 is about falling weights, falling weight deflectometer techniques, telling about and this surface structure. So basically, we are recommending on ROADEX that you should not only look the maximum bearing capacity at itself, but you should look also where is the problem. Is it on the surface area, like mode 1 rutting, or is it problem in the subgrade interface, which we call mode 2 rutting? And that you can calculate, and that information you can get from the SCI surface SCI class or BCI class, and a surface curvature index or base curvature index. And there is explanation and how you do, and also some critical limit, and where you have a poor and what is the extremely poor limit. That helps you a lot of when you need to do the strengthening and designing of that. Finally, good some information about also the roughness measurements, where we've been testing now 3D accelerometers on the roads, where we have an accelerometer under the driver's seat, cameras, and then GPS antenna and 4G, 5G antenna that sends real-time data. So for instance, our system that we've been testing, the data is in 2 seconds. When you are driving the car in your gravel road area, it is on the cloud in 2 seconds. And this is not ROADEX research, but it's published. This is from the Central Finland test area, and very interesting information showing how the roughness changes in the gravel roads. And these are 2 repeated years starting from 2021 ended up 2022. And the worst roughness is always April. Then when the frost starts to thaw, and then it goes down slightly on up to even up to November. There could be some in midsummer. If you have some washboarding, it's a higher values. But quite surprisingly was that the roads are smoothest, gravel roads are smoothest in December, when our gravel roads are frozen about 20 centimeter. And also there's example about where you get the roughness and what is the reason of these different roughness areas. Also this example also how you can detect frost bumps, because frost bumps are only they can be very dangerous on traffic safety issue, but they are only on, let's say, April, May, late March, and normally you are measuring roads only in the summertime. But how do you detect? How you measure? We are showing some example how we be measuring and identifying frost bumps on these roads. Then chapter 8 is maintenance machine and techniques. I'm starting to have going out of the time, so I'll speed up a little bit, talking about grading and blading. And one issue what I have been finding since when I was in road administration, I was part of the team teaching maintenance crews on the gravel road maintenance. And at that time, we were talking about very much on blade angles. And at the moment, I have been seeing some graders and bladers that looks like it's always some fixed angle. And this angle idea should be brought back. So especially when you have a cutting compared with the blading or dragging, or if you are doing light maintenance, this angle should be totally different. And also systems, telling about system, like if you have a corrugation or washboarding, cutting angle should be always deeper than the bottom of the pothole. And this seems to be a quite big problem in many areas now in Finland, and I would say other countries, is that we don't have any of these heavy graders, and many systems are tractor-driven graders, and they are not too powerful or they are not too heavy enough to go to the bottom of the pothole. And once you have like in this, that your pothole bottom is maybe 6 to 8 centimeter, and your cutting depth is only 2 or 3 centimeter. These potholes, like even here, you can see they are back in 2 or 3 days. The other issue is also now when you have contractors that are busy and want to be very effective. The other mistake is that grading speed. Very often you see contractors grading quite fast. And once you are grading quite fast, and the blade starts to bump because it's not so homogeneous, or you have a very high also like tire pressure in the. And here's a nice example, not from Nordic countries, but somewhere south is a grading speed where on the left side grader has been driving slow speed very nice grading, and on the right hand see over here you have been driving too fast and you are making already corrugation. And once you have this, you will have a problem very soon. This seems to be very much forgotten in current days in many countries. Chapter 9 is renovation. A lot of information on that. I'll just skip, but I just want to remind you very nice rule of thumb, which is Mike Pinard, who is a low volume road guru in Africa. And he's been working very much on very challenging condition on low volume roads in Africa. And he has this rule of thumb that there are five main risks on the forest road. And there's material quality, drainage, bad quality construction. There's no too thin layers, or compaction is not maintenance, which is wearing course, drainage or winter maintenance, and traffic, which is overloading. And the rule of thumb is that if you have only one problem, you can handle that with the maintenance. But if you have two problems, then you have to do renovation. And I really like this rule of thumb that when you should start to do a heavy. It's not only maintenance. And as I said earlier already, this classical ROADEX deformation ruling and classification on the diagnostics we are using and recommendation, and also the process, this 14-step process when you are doing a plan and renovation plan for the roads. We don't start to go through that. But on renovation design techniques, we are telling that we are still using many countries nomograms, that you have a current bearing capacity and then target bearing capacity, and then defining how much new aggregates you are needed. But if you want to be more analytical and more precise, and also if you want to save money, what we are showing that you should do the falling weight surveys, and GPR surveys on to get the continuous bearing capacity, and then you can really see where get the real structures. We are providing also typical example of different type of class renovation structures, depending what type of problems you have. And one also addressing one important issue, which is very often forgotten, for instance, if you are using nomograms. The big mistake in many countries and is that once you are doing renovation, you are leaving the old wearing course and then start to build everything on the top. And that means that you have a very plastic, water sensitive, water susceptible material leaving under the roads. And that might destroy the good structures. So basically what needs to be always remember, like in this case, is that you have to have a grader and grade the old wearing course away to the side of the road and then start to build a new structure. Then you can use this wearing course later as a new wearing course, but don't leave it under there. Seasonal changes, and chapter 10, some basic rules why we have surface thaw thickening, structural thaw thickening, subgrade thaw thickening. In Finland, we have only two classes, surface thaw thickening, pintakelirikko, and subgrade thaw thickening, runkokelirikko. But in general, there are three classes, three type of deformation, and also talking about road-friendly tanks. How do you are monitoring seasonal changes like Perco-Station, which have been doing a lot of research on that on the earlier ROADEX project, and also the process. So about the process, how do you make, like how do you know if you have a spring thaw weakening? And the critical issue is how the road is freezing. If it's freezing when it's wet, and the freezing is temperatures are not very cold, then you have a very big, most likely you will have a thawing weakening. But if it's freezing when it's dry, then the risks are much lower. But on the other hand, winter when it starts to thaw, the other issue is that if you have rain in the first part of when the surface thaw starts, you should have always a very dry, windy weather. Then you are safe. But it's a very sensitive the rains on that time. Chapter 11 is finally about environmental considerations, thinking about especially environmental issue on over there, and for instance surrounding habitats and like dusting is a one issue. And gravel roads are very often built very close to the houses that people are building. So vibrations, dusting, and noise is a critical issue. So you have to keep there should be always, when the houses are close, and the road should be very on good condition. The other issue is important issue is culverts, especially on forest road, because fishing might that culverts should be probably installed, because a migration of fishes like trouts or other valuable fishes is impossible if the culverts are not properly installed. And finally, also like humans, like washboarding. Everybody who has been driving washboarding roads, like in this very scenic, nice photo. So you will see fantastic photo. You think that you are in heaven when you see the view, but if you are driving a gravel road with this like a washboard, you feel that you are in hell. So it's an issue also with the, and of course it's a health issue. There are very interesting and um, research results are also about stress. If you have washboarding and high frequency acceleration, you are having stress, you might have a risk for heart problems, etc. Finally, lesson tests. There are 12 themes on the lessons and 61 questions. You can test how well you have been learning, what is there, and it tells you how much, and shows also later on the correct answer. Video links, I would say maybe 60, more than 60 video links from ROADEX countries and also from North America, USA and Canada, about forest roads and gravel roads, and how do you do different type of test on that. And literal review and references. This is very much for students or researchers. Find some links that where we have been finding this our recommendations. So this is pretty much 1 hour spent over there, and this is the final. So there is a lot of example of different type of problems on the roads, but if you are not so much interested on the road problems, there is a lot of very nice, at least on to my eye, very beautiful images and photos of the gravel roads and forest road all over the world that you can also enjoy. So that was pretty much on about gravel road, and you are really like welcome to visit. It's a roadex.org e-learning lessons and gravel and forest road, where you can find this section. So thank you very much for listening. Do you have any questions?